Hey there, everyone. Today we're looking at a multifaceted topic. We're going to look at screen scraping. We are going to extract parent-child relationships from a website, chipotle.com. Pretty familiar. I bet everybody recognizes what that is. And we're going to solve the traveling salesman problem. That is when a salesperson, man or woman, doesn't matter, goes from one point to another and visits all the clients that they have to visit. If necessary, goes back to the original location. It's not always necessary. Sometimes it is, sometimes it's not. But you go to every location and you do so with a minimal amount of effort, with a minimal time commitment, and traveling the least distance possible. So you get to every location and you do it as quickly as you can imagine. Okay, so parent-child web scraping is pretty popular. It's where you will take something in a hierarchical fashion, get data from one web page, click down to a lower level, extract data from that, and then perhaps click down to further additional lower levels and perhaps lower levels after that. So it's at least two levels of hierarchy, right? The parent and the child. If there's multiple children, then so be it. You might drill down multiple different levels. In this case, I think it's just going to be two. So we'll take a look at that, and then we'll solve the traveling salesperson problem. Basically, how Chipotle should deliver its food products. It's all the inputs, the lettuce and tomatoes and onions and beef and chicken and wraps and rice and all that stuff to all the locations and the least time possible and least distance travel. Okay, so let's take a look at this. This is using Selenium. I love Selenium. It's a pretty powerful web driver. It will allow you to interact with a website dynamically and interactively just through code. So it behaves like a human would, going ahead and clicking on links, going ahead and scrolling up and down, back and forth on the web page, interacting with it just like a person would. But of course, it's a computer doing it. It's not a real person. So let's take a look at the website. Should be pretty straightforward. Here's chipotle.com. Okay, and here are all the parents. Here are all the state names, and you can see all the restaurants in each state. So Alabama has 31. Let me click on that guy. Okay, so here's the parent, and here's the children. And, oh, so it has 3 levels. Okay, so here's the children. There's 1 restaurant in Athens. It's 2 in Auburn. There's 3 in Birmingham. No, 4, sorry. 4 in Birmingham. Let's go there. That seems to have the most. A lot of these just have 1 or 2. And here's the 4 restaurants. So Chipotle UAB, whatever that is, Birmingham, Chipotle Trustville, Chipotle Inverness, and Chipotle Chahaba Point. Not sure if I'm pronouncing that right or not, but doesn't really matter. We are going to get the parent relationships and then all the children relationships and then all those addresses, so we know which Chipotle restaurants to ship our products to, our raw materials, all the inputs for all the burritos. So we have the Chipotle website, we have the web drivers at the top, and we have 1, 2, 3, 4, 5 states here. I have a state list of abbreviations. We can tell this is a list object because it has square brackets, okay? And I am going to go ahead and tell the code to click into each link and then extract. This is a state abbreviation. So here's the parent or the anchor URL or the root URL, whatever it's called, the state URL and the state abbreviation. So we're going to append that into each master URL, right, or landing page URL, whatever you want to call it. And then we're going to get all the city links and get all those city addresses when we run this code. So I'm going to go ahead and post this code when I post a video. You don't have to take notes. You don't have to understand all the details and all the nuances of what's going on here. But just be mindful that you are creating a couple loops. Okay, we're looping through a city of links. We're creating links and looping to each link, and then we're going to extract information from that link. Okay, and when we get down to a click event, if we can click on the city like we just saw, that city in, what was it, Alabama, I think, they had 4 restaurants within the city limits there. So we have to go into each link, click each one, and then extract the BeautifulSoup code. So that is the HTML behind the website, right? The HTML is all the rendered text that you see in the page. We'll get the street address, okay, and the city. and the state, and then the postcode, and then the address details, and so on and so forth, right? So if I go back there, how do I know where all this stuff is coming from, right? And it looks a little bit complex, but it's actually not too bad. If I go back to this Alabama, let's just use this. This is a good example. Just the first one. There's nothing special about that. And go to Birmingham. Okay, click on that, and then if I go here and right-click, okay, so I can click on this, but where's that take me? I only go off on a big tangent here, but let me just take a quick look at this thing. This is opening, and okay, yeah, so there we go. So that is the state address. I'm sorry, the business address in the state of Alabama, right? Birmingham, Alabama. If I right-click on this, this is kind of cool. You'll see something really neat here, and go to inspect. I did this on my other screen scraping videos. I have a bunch posted on YouTube right now. You can check those out if you're interested. Right-click on that, and you'll see the data behind this page. This is the HTML. All right, and if we go over here to address row and mouse over that, you see how on the left the address gets highlighted in light blue or navy blue, whatever that thing is right there. 320th Street South. So if you look real closely in this address class, it's called a div class. That's a div element, and you have a span class. It says C address street 1 and C address row. Let me see which one it actually is. There's the lovely black screen. Gotta love that. C address city. So I think that is C address city. Oh no, C address street 1. That's it right there. So that's the class element that you're looking for. So this isn't magic. This has all this logic behind the BeautifulSoup screen scraper. We have C address 1. Right? If I highlight that, that is exactly what you're looking at, and it's pretty much the same convention over and over. You have soup.find class equals, and you see C address street 1, C address city, C address state underneath that, C address postal code. If I go back here, that's exactly what we're looking for, that soup.find class, and we are looking for that element right there. Okay, if I mouse over it, C address street 1. That's how I know what that is. Okay, so that's what I'm telling you to look for. And then if I go over here, C address row div, if I expand this little triangle thing here right there, I should. That didn't do it right. Okay, try it again. Birmingham, Alabama. See, so we get that from address, C address row. So that is a naming convention that Chipotle has come up with. Every single website is going to be different. You can't use this on any other website. You can't go to Amazon or Microsoft or McDonald's or Taco Bell or whatever. They're all going to be different, right? They all have their naming conventions, but that's how you get to it, right? You would right click, like if I want to go to the zip code, I would right click on the zip code and do inspect. Okay, go down here with my mouse, inspect, and click that, and that is going to take me to the zip. Let's zip over to the zip, and now you have it 35233, and that looks like a span class C address postal code. If you look close, C address, C hyphen address hyphen postal hyphen code. You see that thing right there? That should match this over here, that class element. And it does. That's exactly it. Soup.find class equals that between the quotation marks, right? You can use a single quote or a double quote. It's the same thing. That's how you get it. So once you understand that, you can screen scrape all these HTML elements, right? Combine that into a structured data frame, and we can go ahead and screen scrape all our addresses. So let me go ahead and click this. It is going to kick off. It'll take a couple of minutes. I probably should have started this sooner, but you know what? That's okay. That's okay. So we're going ahead and extracting all the elements. I did notice a couple of timeout sessions. So if the web page tends to load up a little bit slow, we could have a timeout event, and that would take us into the accept part of the code. We have a try at the top if I scroll up a little bit. So this is how you handle any potential errors here. We have a try right here. We wait 10 seconds, so we give it ample time for the website to load. Web pages tend to take a few seconds to load. It could take 10, it could even take more. That's why we have the accept. So it should load probably in 10 seconds, but if you have a slow connection or you're running a lot of jobs on your computer and your resources are pretty much used up, this could run slower, right? And it could take more than 10 seconds. So I think this is going ahead and opening up the web browser right there. Let me see if I can jump over there real quick and take a look at this thing. Yeah, okay, so it's running, right? So this is the automation process. So it's skipping through all of the restaurants in Arkansas. I believe AR is Arkansas. Yep, Arkansas. And it's 14. I just saw it. Okay, so it's chugging along. It's doing everything it should. So that's the whole thing. It's going to the parent. That is the state. And then within the state, you have all the cities. These are the children. And then you have children of children. These are all the addresses on the Chipotle website, right? So pretty cool stuff. Now we're in Little Rock. Then we go back and still in Little Rock. Still in Little Rock, okay. I think that's the last one. Then we go back to North Little Rock. Guessing that's just north of Little Rock. And then Searcy. There's one restaurant there. We got that one. And then we go back to the parent. And the original parent is the state. Now we're going on to the next state, so Idaho. So here's the list. I'll take you through it one more time just to be comprehensive and complete here. If we go back here, that is screen scraping all the data as we talk here, and it's going into all the parents, which are essentially this list of 5 states. I'm not going through all 50 because there are so many restaurants out there, guys. It was a little bit overwhelming, and it would take a good portion of the entire day to do that. So I'm just getting 5 states. I know for a fact all these states have pretty minimal numbers of Chipotle restaurants, around 10 to 15, I think, would be the max in some of these states, right? These are not highly populated states, so you tend not to see too many Chipotle restaurants. Some of these states have a lot, like hundreds. You can take a look at the website. So that's it. We have the parents at the state level, the state abbreviations. We're going into each URL, extracting the data relevant to the address. We get the city, the street, the state, postcode, address details, so on and so forth. And we have a try accept because some of these web pages load a little bit slow. I'm not exactly sure why, but we handled that. And this is a very elegant way to get back to the previous level. It's just driver.back. So you were using a Chrome driver. This is Google Chrome. That's the browser that I'm using. I'm using a Chrome driver to do the screen scraping. And driver.back takes you back, as you might guess, to the prior step. Okay, that's how we get the prior address. And then once all of the children addresses are done, we go back to the state list and go to the next state in that list, right? I showed you those 5. One was Oklahoma, one was Montana, I think Arkansas. And that's pretty much it. After everything is done, we go ahead and clean up everything into a data frame. We do address list pd.dataframe to convert the list into a data frame. So just one single line of code to convert everything in that list into a data frame. Here's my list right here. Let me scroll down. We can see where his thing is and the overall progress of things. We are done with Arkansas. Idaho is done, I think. Looks like it. Montana, I think that is done or nearly done. Okay, so it's still working on Montana, and you can see how it's running here. So if I scroll down a little bit, you'll see it's printing out the addresses in a list as it goes, right? It's getting one by one. We're into Missoula. Now we're into New Mexico. I think this is the last one. Albuquerque has a couple restaurants. We'll let that finish off. Should be done momentarily. Okay. Albuquerque, still thinking about it. Okay, there's the first one. So Albuquerque, that's a funny name. So it's 2 different zip codes, so different ends of the town, I guess. And what else we got? There's 3. So we got 3 in Albuquerque. We're doing good. Albuquerque's got good coverage there. Okay, so the list got long enough to create an extended window here. So let me scroll down a little bit, and we can see a few more. That is New Mexico. Okay, so I think we're done with Albuquerque. Okay, we moved over to Oklahoma. Good progress. Oklahoma has 14, 15, 17. 17 so far. And in just a minute, I'm going to show you on the Google map what everything looks like. We're going to find the shortest distance using the traveling salesperson solution or logic, whatever you want to call it. So we are going to go to every single restaurant in the state. I imagine this is how Chipotle does it. If they don't do it, they should do it this way, right? We're finding the shortest distance between all those restaurants. Now, they might not go state by state. They might use regions. They could actually go across states. So maybe one truck driver will cover part of Idaho, part of Montana, part of Wyoming. I'm not sure how they do it. They would have to look at the full comprehensive list. I'm looking at this from a state perspective, so I would go state by state, but actually they might do it by regions, right? If you had restaurants in 3 or 4 different states, but they're considered to be one region, that would probably make more sense for them, right? Like, I don't know exactly how they do it, but they should use some kind of efficient logic like this, traveling logic. So they are traveling the minimum distance, putting no effort, using the minimum amount of time to make all these deliveries to all these restaurants, right? For all the raw materials, all the rice, the beans, the lettuce, chicken, veggies, whatever goes into the ingredients of this thing. Okay, so let me go ahead and go down a little bit, and let's see. I am looking at Montana. Okay, so this in Google Maps, they limit you to 10 destinations. I think that's the limit. You can look at 10 destinations at a time and it'll plot everything on the map. So let me go back here and go up to Montana. I think the code is still running because I see the hourglass on the tab up there at the top of the screen. Where's my, that's New Mexico, where's my MT, about Montana? MT, where are you? Yeah, okay. So you can see as it goes, whoops, skipping, sorry about that. As it goes, where is this thing? Oh. Yeah, there's Montana. Okay, so as it goes, here's the state for Montana and the optimal route. So the traveling salesperson logic is solving the problem for us as we go. We start with Shiloh. We go 0 miles, right? That's the first one. Then we go to Billings, 5.56 miles. Billings again, 12.61 miles. Okay, and we're doing a cumulative count or cumulative sum of distances. We go to Bozeman. Now we're up to 161 miles, so that's a little bit of a trek. 258, 346, 519, and then 638.42. We finish in Kalispell, Montana. I guess I'm pronouncing it right. Kalispell, 638.42 miles. I plotted this just before I started the video. 638.4, and we go to 8 locations, right? So let us take a look at the map. This is what we're seeing. 1, 2, 3, 4, 5, 6, 7, 8, and we go 638 miles, 10 hours, 45 minutes driving. Okay, that's what Mr. Google is telling me right here. And we're going to all these restaurants. If I pull this over just a little bit, just to get that lined up a little bit on the left, we should see that. Go on, adjust, please. Car, and it's going. It's struggling, but it's going. Okay, good enough. Enough for me. Okay, so we have the 8 locations. We traveled to all these 8 as a Chipotle truck driver, and the minimum time and minimum distance, 638 miles, right? And we have details of the map, and that's exactly what the business logic said too, right? So if you go down here, I have a screenshot of the same thing. You see all the addresses there, 638 miles. It's going to take 10 hours, 45 minutes. And that is the shortest distance and the shortest time. So that is pretty cool. We saw the traveling salesperson. We did parent-child screen scraping. And we did the what? Shortest distance and shortest time. Okay, so it's a kind of a complex problem, but we broke it down into bite-sized chunks that we can digest pretty easy and make sense of. I think this was pretty informative, and that is the end. Pretty informative and pretty enlightening. Hopefully you guys got something out of that. I learned a lot by doing this project. Hopefully I can share some knowledge and drop some information on you guys as well. So I will upload the code. You don't have to be taking notes and worry if you miss something. You'll have the code forever. Basically, I'm going to load that. When I load the video, you'll have everything you need. Download the file, double click it. It's an HTML file, and it'll open up. You'll have a view exactly like mine, and then you can run the code in your own Jupyter notebook, take it apart, put it back together, see how it works, and I think you're going to learn a ton. So that's pretty much it, guys. Thank you so much for your time today. And as always, have a wonderful rest of your day. Goodbye.